In this question, we have data that a sports teacher has recorded on the number of press-ups done in students in 2 minutes for both a Year 7 class and a Year 11 class, presented as a back-to-back stem and leaf diagram. In part A, we're asked to find the median number of press-ups for each class. This is not group data. We have the exact values of every single pupil. So we use n plus 1 over 2 to locate the medians. So if we add up the totals for the Year 7 class, that shows there are 31 pupils there and 32 in Year 11. So for the Year 7 class, add 1, divide by 2. That tells me the median is in the 16th position. 6 and 10 is 16, so it's the last one in this line, which is 29. So the median is 29. Same procedure for Year 11, except when I do 32 plus 1 over 2, it's 16 and a half, so I have to consider both the 16th and the 17th piece of data. 4 and 5 is 9, plus 5 is 14. So the 15th piece of data will be here, that's 50, 16th is 53, and 17th is 55. And my median then will be midway between 53 and 55. My median is 54. In part B, we're asked to find the lower quartile and upper quartile for the Year 7 class. First of all, I have to locate where those pieces of data are. So if I think about my data as a full distribution from 1 to 31, we've already established that the median is in the 16th position. That splits the list into values below and values above. So the lower list runs from 1 to 15, the upper list runs from 17 to 31. If I want to find the median of this lower list, that will give me Q1. So 15 plus 1 is 16 divided by 2 tells me Q1 is in the 8th position. That's a gap from the first one to the Q1 of 7. That should be the same gap here, which it is. I apply that same gap now to the 17th piece of data, which takes me to my Q3 at the 24th position. And if it's all correct, this should also be a gap of 7, which it is. So Q1 is at the 8th position. Got 6 pieces of data in that first line. So 7th, 8th will be 22. And Q3 is at the 24th position, 16 pieces of data, plus 7 is 23 pieces there. So my Q3 is this value here, 42. Now it's given us the lower quartile and the upper quartile for the Year 11 class, but it then says use the medians and quartiles to describe the skewness of each of the two distributions. Now to some extent you can see some of this skewness. You can see in the Year 7 class there are more values towards the beginning, whereas in the Year 11 class there are more values towards the high end. And we remember, here's the data for Year 11 and for Year 7 then. But we remember that skewness as a histogram has positive skew if more of the values are towards the low end, symmetrical if it's mostly in the middle but equally either side, and negative skewness if most of the data is towards the end. And we have inequalities for that. So the mean is bigger than the median, which is in turn bigger than the mode for positive skew. They're roughly equal if it's a symmetrical distribution, whereas negative skew, the mean is the lowest value. However, this is not the test we're going to use in this question, because we don't know the mean and we don't know the mode, and it's also told us to use the quartiles and the median. So the test we actually need to use is this one, where we compare Q2 minus Q1 with Q3 minus Q2. On a box plot, you can see if Q2 minus Q1 is less than Q3 minus Q2, the median is towards the low end, i.e. you can sort of see it mirrors what's going on up here. For symmetrical, they'll be roughly equal, and you'll get an even box. Whereas if you've got negative skew, Q2 minus Q1 will be bigger than Q3 minus Q2, so data more towards the high end. If we go back to our question, if we look at these values then for year 7, Q2 minus Q1 is 29 minus 22 is 7, Q3 minus Q2 is 13, so that means that Q2 minus Q1 is less than Q3 minus Q2, so we've got positive skew, and that sort of confirms with what we're looking at here, with most of the data being at the low end. For year 11, if we do Q2 minus Q1, 54 minus 38 is 16. Q3 minus Q2 is 5. So in this case, Q3 minus Q2 is the smaller one. Q2 minus Q1 is larger than Q3 minus Q2. Hence, we have